Welcome to BIO-CHEM Physics Academy. Today we are treating equilibrium of force. A body is said to be in equilibrium. A body is said to be in equilibrium when the body is at rest. A body is said to be in equilibrium when the body is at rest. First, when the body is at rest or stationary. Then when the body is moving with what? With constant velocity. When the body is moving with constant velocity. So when the body is moving with constant velocity, it has no acceleration. Note, when the body is moving with constant velocity, it has no acceleration. And again, there will be no, if the body is moving with constant velocity, then note that there will be no what? Direction. There will be no change in what? In velocity. And if there's no change in velocity, that shows the body is what? Is in equilibrium. And when another one is that when the body is either not rotating, when the body is either not rotating or is moving, is what? Is moving in angular velocity. That is when the body is either not rotating or is what? Is moving in what? In angular velocity. So when the body is moving in angular velocity, the body is said to be in equilibrium. So when the body is said to be in equilibrium when it's at rest. When the body is at rest, the body, or is stationary, the body is in equilibrium. For instance, when let's assume a book is placed on a table. So there's a force, there's a gravitational force pushing the what? The book, and the table too is also what? Pushing the book. So the book remains still. So the book is what? Is said to be in equilibrium. And another thing is that and our equilibrium of force. Yes, equilibrium of force. Equilibrium of force means when all forces acting on a body, it means when all forces acting on a body cancel each other, and it results to what? To no motion what? Change. Is when a body, like for example, is when all forces, equilibrium of force simply means when all forces acting on a body cancel each other, then resulting to what? To no change in motion. That's what? That's equilibrium of force. Equilibrium of, there are two types of what? Equilibrium of force. The first one is what? Is static equilibrium. We have the static equilibrium. The static equilibrium occur when the body is at rest. The first one is what? Is static equilibrium, and the second one is what? Is dynamic equilibrium. Static equilibrium or what? Or stationary equilibrium. So static equilibrium is what? Is when the body is at rest. And I've explained it earlier. And another one is what? Is what? Is dynamic. Is dynamic equilibrium. Dynamic equilibrium occur when the body is what? Is moving. When the body is moving with what? With constant velocity. So when the body, dynamic, another name is what? Another name for dynamic equilibrium is what? Is what? We also name it as what? Kinematic equilibrium. So it's the process whereby when the body is what? Is moving with what? With constant velocity. That's what? Two types of what? Of equilibrium. Let's describe some terms. Let's look into some terms in equilibrium. Some terms in equilibrium. The first one is what? Is resultant force. The first one is what? Resultant force. Resultant force is a single force. I come again. Resultant force is a single force that have the same magnitude and direction. Is a single force that has the same magnitude and direction as a what? As the combined effect. As the all force acting on what? On the body. As the what? Combined effect. As what? As the all forces acting on the what? On the body. The resultant force, I said, is the what? Is a single force. As the all is a single force that has the same magnitude and direction as the combined effect. As the what? All forces acting on a what? On a body. So is what? Is a single force that have the same magnitude and direction as the what? As the combined effect, as the all forces acting on a what? On a body. So the idea is that this is just the concept. The concept is that it tells you what the forces is what is doing on what on the body. Okay, let me use structure to explain it for clearer sake. For example, this is F1 and this is what F2. This is the first one and this is F2. And then so resultant force is a single force that have the same magnitude and direction as the combined effect as what as the combined effect as the all force acting as the all force as the F1 and F2 acting on this particular body. So it has what the same magnitude and direction. So they have the same what magnitude. Magnitude means what size. So now it has the same magnitude what and direction as the what as all forces as what have the same magnitude and direction as the what as the combined effect as the all forces as the what F1 and F2 acted on this what on this particular body. So this it has what so they have what the same combined what effect as what this F1 F2 this F1 and F2 has what has the same combined effect as the what as they acted on this what on this particular body. That's what equilibrium that's what resultant force is. Oh, let me use another diagram for clearer sake. Let me use another diagram to explain. This is F1 and this is what F2. This force is acted at this point. They meet at this point. This is not what the resultant force. So now, as the F1 and F2 is what this F1 F2 was have what the same magnitude and what and direction. This is the directions here. Magnitude, I said it earlier that magnitude is what has the same what is the size. It's also the same is what it's also known as what as sizes. It means what size. So now it has what they have what as this F1 and F2 acted. Let's assume there's a body here. Yes, this is a body now. As this what F1 and F2 is what acting on the body. They have what the same combined effect. That is they have the same what they have the same magnitude and direction. These are the directions here. So they have the same magnitude, the same size, and what and direction as the combined effect on this particular body. As all of the forces is acting as F1 and F2 is acting on this particular body. They have what the same what combined what effect. So this is the resultant force. So as they act, this is the what is the single force. I really want you to understand. Are you following? Like it's a single force. This is the single force that have the same. This is F1 and this is F2. They have what they have the same combined what they have the same magnitude and what and direction as the combined effect is just a single force that has what the same what that have the same what that have the same what combined what effects as a what it's just like they have what they have the same magnitude, which is the size and what and direction. This is the direction and this is actually the size. So this is the size. They have the same size the magnitude. The magnitude is also the same thing as size. So now they also have what? Direction. This is the direction here. So now, so as this F1 and F2 acted on this what? On this particular body, the what? They have the same what? Combined effect. It's not a single force. This is the single force. Now, these forces, this body, they are not in equilibrium. So now, to balance this what? These forces, there should be what? An equilibrium of what? There should be what? Another forces here, known as what? Equilibrant. Equilibrant force. Equilibrant force is just a single force that balance other forces. So in this case, the body, we can say the body is in what? Is in equilibrium. So equilibrant is what? Is a single forces that balances what? The other forces, thereby making the systems to be what? To be equilibrium. But they have the same what? Magnitude. Let's assume we have what? 20 Newton here and what? 20 Newton here. The magnitude is the value here. The magnitude is the value here. So now they have the same magnitude, but what? Different direction to the what? To the resultant force. When it comes to equilibrant is just a single forces that balance the other forces, thereby making the body to be what? The system to be what? To the equilibrium. So they have what? The same what? They have the same what? The same magnitude, but what? Different direction. For example, now this they have the same 20. This is whenever I'm referring to what? The magnitude, I'm referring to what? To the what? The value. It has the same value, but what? They have what? Different what? Direction. So that's what equilibrant of force. So another, let me quickly write the equilibrium of force here. Equilibrant of force. Let me say equilibrium force. Is a single force which when acted on a body, it balance the other forces, thereby making the equilibrium, making the system to be in equilibrium. So now it's just a single forces which when acted on a body is what? It balances the other forces and making the system to what? To the equilibrium. So now let me draw another diagram for clearer sake. This is F1, this is F2, and this is F3. And note the have and they have equal magnitude. They have equal magnitude. They have equal magnitude. But what? But opposite direction to the resultant force. So when we are talking about equilibrant of force, it's just a single forces which when acted on a body, it balance the other forces. So this systems look what this system is what is in equilibrium. This body, we can say this body is what is in equilibrium because there's the presence of what equilibrant force, because it's the single forces that which when acted on a body it balance the other forces, thereby making the systems to be in equilibrium. And they have they really have this they have the same what they have the same magnitude, that is value. If this is 20 newton and this is also 20 newton. So when I'm talking about magnitude, I said it is the value. So now they have the same magnitude, but different direction. If resultant is moving is in southward direction, then if resultant force is moving in southward direction, then equivalent force will be moving in northward direction. So now let me draw another diagram for clarity. This is F1, F2, and F3. Yes. So now the equilibrance of these two forces is of F1 and F2 is F3. The equivalent of force, the equivalent of the equivalent force of of F3 and F2 is F1. The equivalent of of F1 and F3 is F2. So now, and note, resultant force can be calculated or can be solved by using the law of parallelograms law of vector. So we can use it can be calculated using using the parallelogram law of vector. It can be calculated using the parallelogram law of vector. In some cases, you can use Pythagoras theorem to calculate the equivalence of to calculate the resultant forces. Yes, if resultant force you can use. In some cases you can use Pythagoras theorem. In some cases, but actually it can be solved using parallelogram law of vector. So let's and no, there should be a common point. For resultant force or equilibrant of force to work, there should be a common point. There must be a common point for you to calculate any of these particular or any of these forces. You must there should be a common a common point. A common point. So let's calculate some. Let's give you an example. Okay, let's solve this question. An object is acted by two forces of 50 Newton and 12 Newton. Calculate the resultant force if the forces act perpendicularly to each other. To get this to calculate this to solve this question, an object is acted by two forces of 50 Newton and 12 Newton. Calculate the resultant force if the forces acted perpendicularly to each other. B, the two forces act at an angles of 40 degrees to each other. And C, if the two forces act at an angles of 125 degrees to each other. The first thing to do is what? Always 6. Whenever you are given a question, first thing to do is what? List out the parameters. Solution. An object is acted upon by two forces, 50 Newton and what? And 12 Newton. Let's our F1 be what? What? 50 what? Newton. Our F1 should be what? 50 Newton. I'm sorry, it's not 50 Newton, it's 5 Newton. It's 5 Newton, not 50 Newton. It's 5 Newton. And let our F2 is what? Our F2 is what? Is 12 Newton. And the question says the forces act perpendicularly. And the question says calculate the resultant force. We have to calculate the what? The resultant force. If the forces act perpendicular to each other. So whenever a force acts perpendicularly to each other, that shows it's what? It acts in what? At angle 90 to each other. Whenever we hear this word perpendicular, that is, it means the body is what? Is at what? Is at an what? Right angle triangle to each other. It means the body, this is what we means by what? By perpendicular, opposite to each other. So now it means what? Right angle, the force is what? Acts in what? At what? At angle 90 or what? In what? At what? Is in what? Right angle triangle to each other. That's what it means. So now, if let's make this as our F1 and what? As our F2. So in this case, then whenever the body act perpendicular to each other, whenever the forces meet at a point, you know, I said earlier when I was talking about resultant force, they must have what? A common point. So now in this case, now these forces have what? As a common point. So now a diagonal line must be drawn. A diagonal line must be drawn from the what? From this point of intersection. So now that diagonal drawn from this point of what? Intersection is what? Is what? Is our result? Is our what? Is our what? Is the what? Is our resultant? Is our resultant force of line? These are our resultant force. Are we on the same page? The line drawn from the what? From this point of intersection is what? This line drawn diagonally from this point of intersection is what we call is our what? Resultant force or resultant. So now the question now says what? Which what? If the force is we find our what? Our R if the what? We find our R if our resultant force if the body what? Acts perpendicular to each other. Here we have our F1, which is what? Our F1 is what? Is 5. And our what is it called? F2 is what? Is 12 Newton. We have 5 Newton. we have 12 Newton. We have here is what 12 Newton. So in this case, we can use what is called what? We can use what? We can use Pythagoras what theorem to solve this question. Because this is what? This is actually what? Right? If I have to draw it downward, is what? Is right angle what? Triangle. So if this is right angle triangle, we have this, we have our opposites, and we have what? Our adjacents. Then we can what? Find what? Our resultant. Our resultant force is where? Is around where? Around what? Hypotenuse. So now, and Pythagoras theorem is what? Our what? Hypotenuse square is equal to what? Is equal to what? Opposite square plus what? Adjacent square. So now, to calculate our hypotenuse, then we can say what? Our R. Let's read our value. Our R square is equal to what? Is equal to what? F1 square plus what? F2 what? Square. Then we can now say our R square is equal to what? What's our opposite is what? Is what? 5 square plus what? Our adjacent is what? 12 square. So our R square is what? We have what? 25 plus what? Plus 12 square is what? 144. Then our R square is equal to 25 plus 144 should be what? 169. Then here we have to what? Square root the both sides. So now to square root 169. So which is equal to what? By squaring the this cancel this. And what? This cancel this. Our R is equal to what? Square root of what? 169. So our resultant force is now what? The square root of 169 is the square root of 169 the square root of 169 is what? Is 13 Newton. So the square root of 169 is what? Is 13. So our resultant force here is what? Is 13 Newton. Let's move to the second question. Let's move to the second question. The question says what? The question says what? The two forces act at an what? Angle 40 degree to what? To each other. The two forces act at an what? At an angle 40 degree to each other. That is, we should what? Calculate the resultant force. When in this case, we're not giving the what? The question doesn't say is acting what? Perpendicular, but what? But at what? At an angle 40 to what? To each other. So if it is acted, if the forces is act at an angle 40 to each other, then we will say this angle is what? Is 40 degrees. Let's draw the structure. So now this is the F1 and these are what? Our F2. So now it's acting by what? This one is what? Is the two forces act at an angle 40 to each other. So now our F1 and F2 is acting at what? At angle 40, because the question doesn't say it acts perpendicularly. If the question says it acts perpendicularly, then we'll be saying what is in angle what? Is in right angle triangle to what? To each other. Or it acts at what? At angle what? 90 degree to each what? To each other. So now in this case is acting what? At 40 degree, at what? At angle 40 degree to each what? To each other. Here in this case, since is acting at what? At angle 40 to each other. Let me and we draw this without our form from here. These are horizontal force. I said earlier that what? A drawn diagonal line from what? From the point of intersection is what? Is our resultant. Is our resultant. Here now, here we are given what? Angle what? 40 degree. Here is what? Is 40 degree. And here we have what? Our F1, which is what? Our F1 is what? Is we're having our F1 here as what? 40 degree, 5 Newton, and our F2 is what? Here is what? Is 12. What? Is 12 what? Newton. So now the question was we should find what? Our resultant force. Since is acting at angle 40 to each other, then we can say 40 my cut video out. We are using cosine rule. Yeah, use cosine rule. So now let's work the second question. The question was the two forces act at an angle 40 to each other. We should calculate what? The resultant force. Since the body is acting at what? At angle 40 to each other and angle 40 degree. Our F1, these are F1 and these are F2. This is not acting perpendicular to each other, in the sense that if it is acting perpendicular to each other, that's when we can see is in right angle triangle to each other. But we can say it acts at what? At angle 90 to each other. Whenever we are in perpendicular, it means what? I said it earlier. What? It is what? A body is what? it is what angle, what right angle triangle to each other. But this is what it said angle 40 to each other. So now in this case here is what we have the angle 40 here, and we have the F1. The body is what act at an angle 40 to each other. That is why we are using this particular diagram. So now, and I said it earlier that the point of intersection, the line drawn from the point of intersection is our resultant, or resultant force. Although we have to calculate the resultant force. So now the line drawn diagonally from the point of intersection here is our resultant. So now here in this case, let's say this is 40. So now you can put it here, you can put it here anyhow. So now in this case, now we are using what? Oh, we are using cosine rule. We are using what? Cosine rule to solve this particular question. I said it earlier when I was explaining what resultant force, that it can be calculated or solved using what? Cosine rule. Yes, I said it. So using cosine rule, and I said in some cases we can use what? Pythagoras theorem. So now we are using what? Cosine rule. This is cosine formula. Using cosine formula, which is what? Which is r square. Let me see. This is what? R square is equal to what? Is equal to f square, f1 square plus what? f2 square plus what? 2f1 f2 2f1 f2 cos theta. This is cosine formula. R square is equal to what? F1 f2 2 plus what? Plus 2f1 f2 cos what? Cos theta. So now let's use this cosine formula to solve our question, because the angle, the force is acting at what? At angle what? At the 40. It acting at what? It acts at what? At an angle 40 to each other. That's why we are using what? Cosine rule, and we have to calculate what is that force. So now we are using cosine rule. You get this to explain. Our r square is equal to what? What's our f1? Our f1 is what? 5 square plus what? What's our f2? 12 square plus what? Plus what? 2 what? Times what? 5 times 10 cos what? Cos theta. What's our theta? Our theta is what? 40 degrees. So our r square is equal to what? We have 25 plus what? 144. 25 square is 25. 5 square is 25. 12 square is 144 plus what? 2 times 5 we have 10 times what? 2 times 5 10, and 10 that's where, oh, mistake. Here is what? Is 12. So 10 times what? 12 cos 40 degrees. Then our r square is equal to what? 25 plus what? 144 plus 10 times 12 is what? We have 120 cos 120 times cos 40 is what? I think for 40 is around 0.866. Let me confirm. Yeah. Cross 40. Cos 40 is what? 0.766. 0.766. So r square is equal to what? 25 plus 144 is what? 169. 169 plus what? 120 times what? 0.766. Just 120 times 0.766 is what? Plus what? 169 plus 12. 169 plus 0.766 is 91.92. 91.92. So our r square is equal to what? 169 plus 91.92. 169 plus is equal to 5260.92. So our r square is equal to 260.92. We have to scale the both sides. So our r now r is equal to square root of 260.92. Our final answer is what? 16.15 Newton. This is the final answer. Let's have the next question. If the two forces act at an what angles of what 125 degrees to each other. Whereas if the two forces act at an angle of what 125 to each other. So if the two forces act at an angle of what of 125 degrees 125 degrees to each other, you have to apply the same rule that you use we have to apply the same what cosine rule that we use to solve what this, because it's at 125 degrees to each other. So in this case, since it's not right angle triangle and we are even given the what the angle which is what which is which is what 125 degree, I said you have to draw your resultant from what is a line drawn from the point of what intersection, a diagonal line drawn from the what point of what intersection. So now our r here, we can put it here, so is what 125 degree. So our f1 here is what 5 Newton, and our f2 here is what 12 Newton. So applying cosine rule, so which is what, this is our r square is equal to what f1 square plus what? F2 square plus what? Plus 2F1 F2 plus what? Cos theta. So here we can say our R square is equal to what? What's our F1? Our F1, what's our F1? Our F1 is what? 5 into 5 square plus what? Plus 12 square plus what? We have 2 times what? What's our F? 2 times what? 5 plus 5 times 12 cos 40. So our R square is equal to 25. 5 square is 25 plus what? 12 square is what? 144 plus 2 times 5 is what? 10 times 12 cos what? 2 times 5 is 10 times what? 12 cos 40. Then not cos 40, cos what? Cos 120. I'm sorry, it's cos 120, not cos 40. We have 120 and we have 120. So now our R square is what? We have 25 plus what? 144 times what? 10 times 120, 10 times 12 is what? What? Plus what? We have 120 cos 120 is what? Cos 120 cos 1 cos 120 is so now cos 120 is what? Is minus what? Is minus 0.5. Oh, I'm sorry. I think it should be cos 125. Oh, not 120. It's 125 rather. 125. Go for honest. Cos 125. Question the last question, which is what? C, says what? If the two forces, it says if the two forces act at an angles of 125 degrees to each other. So now we find what? To calculate the horizontal force. So we are also using what? Sine rule, because the forces is what? The forces act at an angle of what 125 to each other. That's why we are using cosine. Since it's not acting perpendicularly to each other, then we can say we are using the same structure as earlier. This is what 125 degree. So and our R is from, we have to draw a diagonal line from the point of what intersection. So now here we can say we are using what our R square is equal to what is equal to f1 square plus what f2 square plus 2f1 f2 cos theta. So now our R square is equal to what our f1 is what is 5 square plus what plus 12 square plus 2 times what's f1. Our f1 is what 5 times 12 cos what 125. So now you can say our R square is equal to what 125 plus what is what 25. That's 5 square is what 25. 12 square is what 144 plus 2 times 5 is what you can say 2 times 5 is what we have 10. 10 times what 2 times 5 is square times what 120. 10 times 12 is what our 10 times 10 is what is 120. Let's see, 2 times 5 is what 10, and 10 times 2 times 5 is 10, and 10 times 12 is what 120 cos what theta. So our R square is equal to, we have 25 plus what 144 plus what cos 125 is what cos 125 here. So our cos 125 is 0.787. So here is equal to what 120 times 0.787. So now 0.787. So we can say our R square is equal to 25 plus 44 is what is 169 plus 120 times 120 times 0.797. 120 times 0.797 is 96.64. So our R square is equal to what 96.64. 96.64 plus 169 is equal to what? Is equal to 265. 265.64. So now our R square is equal to what? Square root of what? Is equal to 1265.64. By squaring the both sides, then our R is equal to what? Square root of 264. Square root of 265.64 is equal to is what 16.2 Newton. So now our resultant force is what 16.2 Newton. Let's quickly move to another example. Example 2. The resultant of 246 is 12 Newton and 5 Newton is 30. Of 12 Newton and 5 Newton is 30 Newton. What is the angle between them? Here we have to look for the angle between between the 246, and we are given the resultant forces. Let's list out our parameters. We are given our F1 here is our F1 is 12 Newton, and our F2 here is 5 Newton. The question is, and our R is 30 Newton. Now we have to find the theta or angle between here. The theta, which is the angle between the 246. Now to calculate the angle, we are using cosine. We are still using cosine rule. Yes, we are still using cosine rule. No, because we have to find the angle between the two forces. Here we don't know whether it is right angle triangle, but using the cosine rule will help us to confirm the kind of angle is it. So now by drawing the structure, and then our resultant force comes this way, which is 13 Newton. Our F1 is 12 Newton. Our F2 is 5 Newton. So now here we are using our R square is equal to F1 square plus F2 square plus 2F1 F2 cos theta. So now our R square, which is 13 square, is equal to 12 square plus 5 square plus 2 times 5 times 12 cos theta. Cos theta. So then our 13 square is Our 13 square is 169, which is equal to our 12 square is 144 plus our 5 square is we have 25 plus 2 times 5 is 10. 10 times 12 is we have 120 cos theta. Here our 169 is equal to 144. 144 plus 29, 25 rather, is 169 plus 120 cos theta. So 169 is equal to this one will cross to this part, it becomes minus 169 is equal to 120 cos theta. Then 169 minus 169 minus 169 minus 169 is 0, which is equal to 120 cos theta. So now to divide both sides by I divide both sides by 120 divided by 120. Then 120 divided by 0 divided by 120 is 0. Then we can say 120 cos what? We can say this cancel this. 0 divided by 120 is what? Is 0. Then you can say cos theta is equal to what? 0. So now we are dividing both sides by what? Cos. So this cancel this. Then will be what? Our cos inverse of what? This can our cos cancel this. So this will be what? Cos inverse of what? It will be what? Cos inverse of what? 0 is what? So the cos inverse of 0 cos inverse of 0 is cos inverse of 0 is what? Is what? Is 90 degree. So now our result, the angle theta is what? Is 90 degree. Thanks for watching.